So good morning or good evening. My name is Laurent and I am from the marketing team. Today, I'm pleased to welcome Mathieu Ferry, head of the product team at 4D. He will be presenting a 4D webinar on 4D21 and the AI kit, showing how they can add value to your business applications for your customers. It will be a 60 to 90-minute session, depending on how curious and interested you are in this topic and how many questions you have. For your convenience, we have split the event into two 30-minute presentations with a Q&A at the end of each of one. The first part will focus on semantic search and how it uses sentences to retrieve information. In the second part, Mathieu will go into detail about tool calling and RAG. If you don't already know what these concepts and terms stand for, you're in the right place. Mathieu will explain everything starting with the basics. I leave you in Matthew's hands. Have a great session.
All right, let's get started. I'm glad to talk to you today about two topics related to artificial intelligence and how you can use it in your 4D applications. The first topic is semantic search or semantic querying. In other words, how you can query your application not with attributes and a conventional order query, but using a natural language sentence. The second topic will be tool calling through an AI model. And we'll see that with tool calling, we can set up what's called a RAG for retrieval augmented generation. A RAG lets you create chat sessions, for example, where a generative model is enriched with your own application data. Now, these two topics, they don't necessarily have to be implemented together. You can do semantic search without a RAG, and of course you can build a RAG without relying on semantic search. But as you will see, these two techniques, they actually fit really well together. Everything that I will show you today is possible as soon as you're using the latest 4D21 or later, and also once you add a simple dependency to your project, for the AI kit dependency. You just go to your project dependency and you ensure that you have the 4D AI kit component here loaded. Okay, this component you will see it does a lot of things for you. Okay, let's now start with semantic search. As I was saying, semantic search is all about making it possible for you to query your database not through traditional order queries with filters on table attributes, but simply by typing a natural language sentence, just like a user would naturally type it. To set up a semantic query or a semantic search, you need a few key things. The first key thing, of course, is data. You need data because without data, there's not much to search through. So let me show you the structure of this demo application. Yes, you will have access to the code. Here I have people, I have individuals, each with a set of skills. We'll see later that those skills include development skills, management skills, HR, and so on. Each person also has a job description with a hire date, a job title, some HR notes, and a daily rate. We'll play around with that later. Each person also has an address. We have here people located all around the world. The goal of this demo application is to be able to query it, for example, to build project teams when you have to respond to a call for tender. That's the idea. Okay, so we've got the data, that's one part, but the most important thing we need for semantic search is vectors. Yes, because semantic search relies on vectors, and we obtain those vectors using a vectorization model. Okay, now instead of saying vectors, I'm going to start saying embedding because that's the term you will see most often. And really, embedding isn't such a scary word. It's basically just a vector. In fact, you can see here in my person data class that I have an embedding attribute, and it's of type 4D.vector. So here's the principle. An embedding is a vector, a sequence of numbers, but it's a special kind of vector because what's encoded in those numbers isn't just arbitrary values, it's meaning. It represents the semantic meaning of a piece of text that we've sent to a vectorization model, also called an embedding model. All right, so now we are going to see how to vectorize all these people. I mean, how to assign a value to this embedding field in our database. So let's take a look by running the demo. All right, bringing the window. Okay, we'll zoom a little bit. All right. To get those vectors, you will need, as I mentioned earlier, an embedding model. And these embedding models are made available to you through what's called inference servers. Now, inference server might sound a bit technical, but it's actually quite simple. It is just a server that runs a model, whether that's a generative AI model or an embedding model. In this demo application, I have here 3 inference servers configured. The first one is OpenAI, where the inference server is hosted in the cloud. Then we have Ollama. You've already seen Ollama if you followed the previous webinars, the 4D 20R10 webinar. But today I'll be using LM Studio, which I personally find super convenient for development. So whatever tool you use, it's up to you. In the demo, you will find the download links, but honestly, just search them on Google, you'll find them right away. Once you have installed LM Studio here, it's really straightforward. On Mac, you get this little icon here. And from there, you can start to search for a model. If you're looking for an embedding model, just type embedding with 2Ds, it's better. And then you will see a whole list of available embedding models. I recommend sorting them, for example, by most download, most liked, or best match, whatever helps you find a solid one. And this here is one of the reasons I like LM Studio, because it gives you plenty of useful details about each model before you download it. So really, don't hesitate to spend time playing around with this interface. Okay, let's search for another model, Quen3. We will use it afterwards in this demo. But here, pay attention to this green tag here. It gives you the information that you can load the full model into your GPU. It's very important for performance. Okay, let's check out another important information here. Here you see this blue icon here. It tells you that this model has been specifically trained for tool calling, which is the second topic we will review today. Okay, I think we've finished with LM Studio. Just don't forget to activate developer mode to get more features. And in another screen here, the chat screen, you can directly chat with the model you load. So here we can send it a hello again. And that's it. The model here that responds is loaded on my machine locally. Generally, whether you use LM Studio or Ollama, you can use the models you load with 4D and 4D AI Kit because they support the OpenAI API. When I will say OpenAI today, I will sometimes mean the company in the cloud, so the inference server in the cloud, and other times I will mean the API. So you will understand me depending on the context. Okay, so let's clear the logs and we'll put LM Studio right here on the side for later. All right. So to do semantic search, what you need is embeddings, so vectors, and you obtain those vectors from an inference server where you have loaded an embedding model. Today, we'll use an embedding model called MXBay. I can show you here. And I will show you how all of this works. To move quickly, I will generate a person record, so just one. I will not re-explain how I create this person. I covered that in details for the 20R10 webinar. So here I generate a person with skills and job descriptions and an address. Okay, but this person doesn't yet have any vector, so no embedding yet. Let's go to the right place in the code. We set a breakpoint here, and we will start the vectorization. Let's go. Okay. Let's dive in the vectorize person function. And okay, here I've written a small vectorize function. And this function is responsible for vectorizing the person. But for a given person, I don't send the entity to the model. I could do that, but instead I've chosen to build a descriptive sentence. Let me show you how that works. I remove that and dive in. Okay, at the end of this function, you'll see that what we will send to the model is simply a sentence describing the person record along with all the related attributes. I prefer doing it this way rather than vectorizing a JSON representation of the record. Why is that? It's because building a full sentence helps the model capture meaning. It gives context to the embedding we'll get back. If we just vectorize JSON, we would still get a vector, but the links between pieces of information would get weaker. Remember, users in your applications, they don't search using JSON text or JSON attributes. They search using sentences, so we're making sentences as well. It makes much more sense to generate the embedding from a natural language description like this. Also in this example, I'm writing the sentence in English, but I could also create embeddings in French or in German if I wanted to. So I build a sentence that basically includes everything I know about this person. It's important to understand what happens behind the scenes. The embedding process takes the text you send, in this case our descriptive sentence, and passes it to the model. The model then analyzes that text and it will map its meaning. That mapping, that semantic representation, is what comes back as the vector. Doing this for the AI kit is pretty straightforward. You create an AI kit client and call the function embeddings.create. You pass two things, the string value, so our descriptive sentence, and the embedding model we selected for vectorization. This one. Okay, so the result is obtained in result.vector, which gives us a vector of length 1024, which is the length of the vectors of embeddings returned by MXBay. Just now put this embedding in the person entity and save it. And we're finished. Let's remove the breakpoint here. And there we go. I've now vectorized the person I just created. It's really important that all your data to be vectorized with the same model. I mean, for a given vector field, of course. You can absolutely have multiple vector attributes in your data model. For example, one vector for employees and another vector for invoices, and so on. But for each vector field, all embeddings must come from the same model, so they are consistent. That said, you can perfectly mix models across different domains. For instance, your invoices might use OpenAI embeddings, while your employees use Nomic or Quint. That's totally fine. What you must avoid, however, is having one part of your entities vectorized with one model and another part with a different model for the same vector field. If you do that, the cosine similarity will not longer make any sense. The vectorization process itself is quite fast. I can here, for example, revectorize my entire database. Let's go. As you can see, since I'm using LM Studio, I get live logs in the background showing what's happening. We'll let that finish. So right now I'm revectorizing my 600 entities using Nomic. Nomic produces slightly smaller vectors compared to MXBay, but it performs just as well. It depends on your use case. Okay, now I can switch back to MXBay so you can see it's running again. Notice that everything here is running locally through LM Studio. I'm not using OpenAI in the cloud. The whole process is done on my own machine. MXBay produces slightly larger vectors, we saw 1024, and it's a little bit slower during vectorization. Let's take a few moments to review a question that always comes up. Which embedding model should I use? Honestly, it depends. I would recommend reading up on the available models online. It really depends on your use case and what you need in terms of performance and semantic accuracy. The key is to evaluate whether the model is able to capture enough meaning based on the text you're sending it. That depends a lot on the kind of feature you want to build. So really, the best thing is to try and compare. All right, so now I've vectorized all my people. That's it. And next, let's move on to semantic search. In other words, how to connect and compare an end-user sentence to our vectors. We will open this method here. And let's break it down step by step. This is how semantic search actually works. Now that we already have our vectors, what we need is a search text. So here I propose a manager or leader, expert in HR policies, living in France. This is the text we will search. And the next step is to instantiate an AI Kit client. That's super simple, literally one line of code. And since I'm using a local inference server, I just provide its IP address here, so you can find the IP in LM Studio right there. You don't need any API key because the inference server runs locally. We now need to obtain the embedding for our search text. This is also just one line of code, as we saw earlier. So AI client.embedding.create. Here again, I'm using the same embedding model I used earlier to vectorize my data. Once that's done, I get back the search vector. And now comes the actual semantic search part. We create a search object, and in it, we store an attribute for the vector, the metric. Most commonly, we will use here cosine, though others are available. Check the doc for that. And also, we will specify here a threshold. The threshold defines the minimum similarity required for results to be included in my search. And the next step is to use this object in another query because we have integrated everything in the other syntax. And here I get an entity selection of 149 entities out of 621. Those entities in my selection, they have a cosine similarity above 0.5 compared to this phrase we were searching. Okay, it's still quite a lot. So let's try to increase the threshold. Let's go back here in the code. And in the object here, I will set a threshold of 0.6. That's it. Let's run the search again. And I get only 19 entities now. So I went from 149 to just 19, which is much more precise. There's a big difference between 0.5 and 0.6 regarding the similarity. A difference of 0.1 makes a huge impact on the entities you will get. Next step is the sorting of these results using an order by formula and using the cosine similarity for the vectors. Starting with 4D21R2, you will be able to use the order by directly within the order query. But for now, this approach works really fine. Oh, and before I move on, note that the metric and the threshold attributes are optional in the search object. So you can simply include the vector if you want to rely on the default values, which are cosine similarity and the threshold of the 0.5. And to make sure everything worked properly, I prepared here a collection so that we can inspect the results. So here you can see that we have 19 records. Let's zoom in a bit. So the first record returned is Marie Dubois. She is an HR business partner. And remember what we were searching for. We were asking for manager or leader, expert in HR policies, living in France. That fits perfectly. Marie lives in France and she's an HR business partner. The second record is Sophie Bernard. Same thing, same kind of profile, and so on. Now, as we move further down the list, and remember that we've just sorted that list by similarity, so the farther we go, the more distant the meanings become. For instance, here I get an IT project manager in Canada, so it's not that similar anymore. The similarity score is likely much lower. The key takeaway here is that the absolute similarity value is not what matters most. What really matters is the ranking of your semantic search result, because it's those top results, the first, the second, maybe the third, that are the most relevant. In your user interface, you will likely want to display those results anyway and let the user decide whether they match their intent or not. Semantic search, unless you set a very high threshold, will always return results. It's just a matter of how strict you want it to be. So the threshold is your turning knob. If you want to give users more options, keep it around 0.5 or even lower. If you want results that are really close and highly reliable, then you can raise the threshold. I really recommend playing around with it and find out what's the sweet spot for your data and the usage you expect in your application. And of course, since all of this is integrated into other queries, you can mix semantic queries and conventional filtering. This is to get the best of both worlds. So order filtering, precise filtering, and semantic search together in the same query here. So I added here a filter on the billing rate here, but still I will be using the same vector. So what I want is people matching my semantic search, but with a billing rate under 1000. So we will execute now this search and apply here the same ordering, and we put that in the collection. So the collection is updated and we now have only 4 entities left. So and all of them have a billing rate under 1,000, like we specified. And the first one, the first record, Sophie Dubois, she matches our search. She's an HR specialist and she's paid under 1,000. So that's a perfect match. Here, we still have a similar record. Isabelle Dufour, she's paid under 1,000, but she lives in Canada, so it's not much more France. The third one lives in France, but it's not much like an HR guy anymore. He's more of an assistant project manager, so it's close, but not quite. So this is what similarity search can give to you. Okay, now it's really easy to wrap up all this logic into a single function. You are pros at that. So here I built a person search by vector function, and I can use it just with one phrase here. So I ask it someone who knows for the development, and I added another parameter to limit the amount of records returned. So here, let's put it to 10. So I can just execute this search, this function, and put it in the same collection. I now get 10 records, and these are the 10 best records matching my search, so with 4D skills. So there you go. Now semantic search has no secret for you. Let's take a look now at how that works in a UI screen. So here I've built a simple interface where I can search for something like for the developer, for instance. Okay. Or I can type also for the programmer and run it. So the results, they might not be exactly the same for both searches because each time I click the search button, the model, and you can actually see it behind the scenes here, it's LM Studio, the model is generating a new embedding for my query. I can also use a French term like programmeur 4D. As you can see, vectorization happens automatically. The key idea behind vector search is that the richer the text is in meaning, the better it works. And by richer, I don't mean longer. I mean semantically meaningful. That matters both when you're vectorizing your data, we saw that earlier, but also when users type in their text. Of course, you have less control over what users type, but for instance here, if I use the term React, we have results, but they won't be as good as if I use a more accurate expression like React front-end developer. That's much more specific. Okay, I mentioned earlier that it works across languages, so even though I used French examples, it's working. I can also type in Spanish, like desarrollador internet, and it still works. That's because embedding model, they somehow transcend languages. Most of them are multilingual. You can usually check that out in their documentation, and you can use them in different languages without issues. However, keep in mind that in my setup, the data was vectorized in English. So my searches will, I think, generally work better in English. If your users are primarily French speaking, it would make more sense to vectorize your data in French instead, or in any language they use more often. Okay, so now let's move on. There's a few limitations to semantic search, and we have to talk about them. The first one, which is actually tied to its strength, is that it's a bit of a fuzzy search. And because it is fuzzy, if you have very specific intent, you will need to combine it with more precise filtering. For example, if I search for the top 10 highest paid people in the company, semantic search will find people who are well paid. If you really want the top 10, that's something you should handle with a conventional ORDA query instead. The second limitation is that users may type complex or ambiguous sentences. For example, here I will search a React developer and a 4D programmer and a project manager, and I will add a HR specialist. All right, so searching that will give me results. In fact, semantic search will try to match all this meaning. But you understand that in fact here, I was not searching one profile, but in fact I was searching several profiles here. So if someone happens to match all the meaning conveyed by this sentence, I will find it. So Lena Chen here probably have a very mixed profile. But you understand that here we've reached another limitation to a basic semantic search. I propose you now to do a little break and to continue later.
Thank you, Mathieu. So before passing to you to answer all participant questions, quick updates. Yesterday, during the 4D Method user group, you did a presentation also about 4D21 and AI, but more in an AI-assisted programming angle. Replay is already available, and I will share with you the link to the user group portal in the chat. 4D, AI, and programming again. In case you would have missed it, I recommend all of you to play a 15-minute video posted on Discuss on how using AI to create 4D forms linked to a business logic. You will be surprised how efficient this approach is. I will also be sharing the link in the post, so I'm doing it now. Okay, Mathieu, it's time for you to answer participant questions. We have two of them.
Okay. Yeah. Hello, everyone. Uh, just before answering questions, yeah, I can talk a little bit about yesterday's 4D method. I know that some of the participants today were already with me yesterday evening. It was the evening for me. And if you were not, I really recommend you to watch the replay on YouTube. It's already available, and it's a perfect match. So when we finish together, if you still have 2 hours and a half ahead of you, it's the perfect next episode. You will see that. So really go and watch this replay. There's so much to tell about AI. We have a first question here. Each customer would need to install LM Studio on their local computer. No. Depends on what you mean about customer. But there are maybe two wrong assessments here. First of all, I would not use LM Studio in production. LM Studio is really good while you are developing, while you are testing different models, but I don't think it would take the load of a production environment. So for production, you would need another inference server, maybe Olama, or maybe Olama is a little bit better, perhaps, or other solutions like maybe llama.cpp or VLLM. It will be, I think, a topic we will cover in a next webinar. So LM Studio is very good for you to have access to a lot of models, to have the logs, to play around with them before even using them with 4D, because you have the chat interface. So it's really good for that. But in production, no. And second part of the question, so you have to deploy an inference server aside to your 4D server application. Yeah, they must work together. It's not to be deployed on each end user computer, of course, would be a little bit messy. For me, the way I see it is that the embedding process must occur server side, but it can be quite heavy. Vectorization is not so much. It's not so heavy. It's not so time consuming and so on. It still takes a little bit of time. You saw that in the demo, but it's not too demanding in terms of computing resources. So maybe you can have your inference server on the same physical machine than your 4D server. It's not the case for generative models. Generative models are really heavy. If you want to deploy them locally, you have to dedicate a machine for that. So I hope I answered the question. Second question, for the vectorization of a specific table, we should always use the same model to ensure consistency. That's right. However, since models evolve rapidly, that's true. How can we guarantee long-term consistency when the current model may no longer be available in the future? That's a good question. Once you have selected a model that suits your need, in fact, you get it locally. So if it's not available in the future, you still have it. It's a big file that you download. But that's true if you want to use another model, you will be able so to deploy it, but you will have to re-embed your records, because if you are not using the same model, the similarity won't work anymore. So if you change models, you have to recompute your embeddings. It's a bit like an indexing process. In fact, it's very similar. Yeah. And if you use an embedding model in the cloud, like OpenAI, for example, but there are other options, usually they are maintained for a long time. OpenAI still gives you quite old embedding models. They are not discontinued, but yes, there's a risk in the cloud that the embedding model disappears and you don't have control on that. Shall we have the link for the French version? Yeah, you will. You will. Another question, what is the best way to start a project? Oh, the question is, I don't have, the question disappeared. What is the best way to start a project? Define the target as example, looking for delayed customer orders delivered, then define the data, then do the vectorization, make the UI. Oh, it's a very big question. I think the best way to start a project would be to imagine the feature you want to propose. What would you imagine? What would you need as an AI feature like that? And then think about what's relevant to embed. Not all data are relevant for embedding. And you start playing around, creating. Yeah, as you saw, one embedding attribute can receive the meaning of a lot of tables. So there's a kind of architecturing going on here, and this is where I guess your expertise as a 4D developer, where you are a lot working with the users and you are also a lot technical. This is where I think your value is. You will somehow define for an embedding attribute what's meaningful to embed, and then you're right. There's also an impact in terms of the UI, because you notice it will have an impact on your UI. We will discuss that maybe quickly afterwards, and we discussed that yesterday a little bit also in the 4D method. So yeah, it's a complex question. I don't know if I answered properly, but I would start at least playing with the thing. Honestly, it's by playing with it that you will find your marks. To get the best results, does it make sense to do the vector modeling with a customer to see the results step by step? I don't really understand that question, what you mean exactly. Maybe I understand. it's true that you will need real data to really test or assess if an embedding model or not is good for you. You will need real data. So if this is what you mean by working with a customer, yes. So how robust are vector embeddings between various versions of a given model? And there's a similar question from someone else. Is it important? It is important, sorry, for the same model version to be used when embedding. So is it? If the model gets updated to a newer version, will previous embeddings need to be recalculated? So to my experience, yes, you should recalculate your embeddings when you upgrade your model. Why is that? Because the cosine similarity operation that we use in 4D, that everybody uses in AI area, it's a very sensitive operation. So even the slightest change in the way vectors are calculated, it will have an impact on the operation. So if you just update the model version, it will probably compute the meaning in a slightly different way, and it will produce slight differences in the vector. So you will get, I think, perhaps the similarity will still work, but it will be less precise. As often, I think the best way to assess this is to test, and you should test every time you upgrade the model. But personally, I would recompute it. And if you have a lot of records to recompute, perhaps you should consider having an additional vector field where you will recompute everything with the new model while keeping the old one. And once you have recalculated everything, tested everything, you just do the switch. But this way you avoid downtime. And perhaps with just an alias or something like that, you can switch between both. But yeah, I would recompute when I upgrade the model version. So that's it for the two first questions. For the third question, I think the answer would be the same. If I have a function to create a text for vectorizing, will I need to revectorize if I make any changes to this text function? How sensitive is vectorizing to small changes? Yeah, I think that it's the same question. It's even more necessary if you update the descriptive phrase. If you add content in it, the vector will be very different. It's very, very sensitive. You see in the demonstration, when I increase the threshold from 0.5 to 0.6, the impact is massive. I just eliminate the majority of the records. So it will be similar if you change the content from the descriptive phrase you use to embed. So I would recompute also. How do we install LM Studio locally on a computer? You just download it. You search for LM Studio on Google and you will get the installer. It's so simple. It's really 5 minutes, but it's more for development. I would not use LM Studio in production. Where can we download the example? You will get it in an email just after this session, but it's already on GitHub in 4D report. If you search for it, it's already a public repo, and it comes with the data already in and the embeddings already calculated. If I have a large database, I think it would make sense to create a separate table for embeddings. Yeah, why not? Yeah, for sure. This would allow specifying the model to the data. Yeah. And when the model changes, I make a new set of records. Yeah. This would be small records and avoid the churn on large record. Yeah, why not? Yeah. There's a lot of strategy. I mean, it's kind of a new world, you know. So there are strategies to choose and to build on that. Re-embedding is a permanent job in a living database, right? Yeah, right. So it should be no problem to re-embed the complete data. Yeah. I think you need to have some kind of running process in background, detecting when an entity changed and decide then to re-embed. In 4021, you may have noticed that now we have order events. So it's not so hard to, let's say, when there's a change in an entity, to just put the vector field to null and then have a background process that detects all the embeddings that are null and recompute them, for example. And it's not necessarily a bad thing. I mean, the embedding is still there until you recompute it. So maybe it won't be 100% accurate, but as you notice anyway, it's a fuzzy search. The strategy here, it's up to you on that. Okay, in your demo, embedding is done manually in a live system. How do you ensure that new records are embedding and maintained without re-embedding the whole database? Table trigger. Yeah, but that's what I just answered, I guess. You could use order event. Don't put the embedding process inside the order event on a saving event, for example. It would be a little bit harder to, I think it would slow down your application. Put that in a global running process. And we are preparing for 21 a component that will help you for that. We're working on that. Something that would help you maintaining this. All right. Maybe we can continue. Yeah.
Yes. So thank you, Mathieu. If we have some remaining questions, you will cover them after the second part. So let's quick move to the second part of the presentation, as we have a lot of interesting topics to come again. So don't drop out the session. Mathieu, to you again.
Okay, let's continue. We were reviewing earlier that semantic search can be inaccurate or irrelevant when it comes to some complex phrases or complex queries. And to solve this kind of situation, there's really nothing better than a large language model, an LLM. Only an LLM can understand that this query should not be treated as only one search, but as four separated searches. And it's a good moment to transition to our second topic for today. I'm talking about tool calling and RAG. So let me show you what kind of results we can get. I will cut this sentence and paste it in this other screen here. And I will use here OpenAI in the cloud and run the query, and we will watch what happens. Let's give it a moment to process. So I will try to explain everything that is going on right now in this view, but I think you can already guess what is happening here. All right, it's finishing. Okay, let's scroll up a bit. Okay, let's check what's going on behind the scenes. We see here in LM Studio that we had 4 embedding requests. So locally, okay, but we used a cloud inference server, so OpenAI, and specifically with GPT 4.1, the GPT 4.1 model. Okay, and we sent it, in fact, this prompt. Now, as you know, OpenAI, by default, has no knowledge of your application's data. ChatGPT doesn't know your app data, neither does Grok nor Gemini. So what happened here and what 4D AI Kit now makes possible in 4D 21 is that we augmented our request, our system prompt, by telling the model that it had access to a set of tools. A set of tools it can call if necessary to answer the user's question. In fact, basically to complete the text it was asked to complete, because we're talking about completions here. And that's exactly what happened here. The model used the function I showed earlier, so the vector-based person search. The LLM itself figured out from the sentence that it was actually dealing with 4 distinct profiles: a React developer, a 4D programmer, a project manager, and a HR specialist. So it automatically called my 4D application and asked it for results related to each one of these profiles. And then it incorporated those results into its final response, because those results were part of its context. And this is what you can see here in this table. For example, Lena Chen shows up as a front-end developer. The model correctly identified her as a React developer, and you can see her React skills right here. For the 4D programmer, we have Lilia Avelar, who is listed as a senior 4D programmer, which fits perfectly. The project manager is Adele Mendoza, a senior project manager. And for the HR specialist, we have Julia Muller, based in Germany, who indeed is a HR specialist, and all this checks out. This is what's known as RAG, or Retrieval Augmented Generation, a generation that's enhanced by retrieving data from your own sources. In this example, it's running in the cloud, but I'll show you later how to do the same thing locally. So let's see how it works under the hood. I'll walk you through a bit of the plumbing. We'll look at the class that's used behind this form. Let's hide this part, it's not important for now. We'll set a breakpoint here, update it, and then ask it a new question. So, who knows HR in France? Oops, made a typo here, we're okay. And there we go. Right away, we start here with nothing. The AI bot starts from 0, so it knows nothing. And the very first thing we do is initialize it right here with this function. And now you're looking at the heart of the reactor. Let's zoom in. As you can see, there's quite a bit going on in the prompt. And for those of you already working with AI, you know how crucial the system prompt is. Here, I tell the model to behave like a helpful assistant and that I will be asking it questions about the people stored in my application. So I'm preparing it to handle that kind of query. This application stores employee data for the company. I also explain what kind of data it contains, so it has some context. Then I tell it to analyze each question step by step, which helps it develop a reasoning process. That's pretty important. And finally, I tell it that it will have tools available to answer questions and that it should use them whenever necessary. That's essentially here the most important part, apart from the tooling section we will look at in a minute. For formatting purposes in the UI, I also ask it to format its responses in HTML and to use table where appropriate. Let's see where it is. Ah, yes, it's here. So I even made a small typo, but you can see I told it here. Don't hesitate to use summary tables to illustrate your answers. Okay, then I add some standard conventions. I tell it to use a valid JSON with the required arguments and not to call with empty arguments. At the end, I also ask it to insert a comment section in the HTML listing the IDs of the people it will mention. That's how I'm able later on to capture those IDs and display them in the list box you saw on the right side of the interface. And that's basically it. I'm using streaming mode, so I can see the response appear in real time. Depending on your use case, that can be handy or not, it's up to you. But because I'm in streaming mode, I defined a callback on data and a callback on terminate. I show them to you later, but there's not much inside really. Now, this part here is for tool calling. Depending on which inference server you use, or Llama, LM Studio, or OpenAI, the exact supported values aren't yet fully standardized from what I know. So that's something we can refine maybe later in that demo. Then I can instantiate my chat client. So I'm using the chat helper class from for the AI kit, and it's really a great class because it automatically stores the entire conversation history. Every completion request and every response exchange with the model are stored there. If you were using just the basic completion API, you would have to handle that manually by yourself. So I really recommend using the chat helper. We'll see that. I create here the chatbot like this by passing the options and the system prompt. And there we are. Our chatbot is ready. So now all we have to do is to load the tools. So let's dive in. I have here a JSON file to describe the tool, and I will show it to you. Okay, it's here. Let's zoom in. Okay, you'll need to do a bit of work by yourself. We can do everything for you. You will need to build this kind of JSON file, which is a kind of declarative tool definition for the AI model. In other words, here I'm declaring 4 tools, 3 simple tools, one to list skills, one to list cities and countries, and the last one to list job titles. So that allows the model to get a bit more context for queries that might be a little bit tricky. So those first 3 tools, they don't take any parameters. So the parameter object is simply empty. But the main tool I declare here is the semantic search we have been looking at earlier. You will need to give it a usage context, so you could skip that part, but your results won't be as good. Here, I just explain what the tool is for, what it does. I tell the model that it's a vector-based search, so semantic search, and I explain which information has been vectorized. That helps it to be more accurate and more relevant. I also tell it when it should use this tool. So this search takes, as we saw earlier, an input value, and that input is simply a text string. In the parameter object, so there's an attribute called terms of type string. And here I described how to build that attribute in more details. I also give it an example of the kind of data that was vectorized in the database and that helps it form better queries on its own. In short, I'm giving it the specs it needs to use this tool properly, and LLMs are really good at this. That's actually one of the reasons I love semantic search in this context. A large language model is excellent at formulating queries in natural language. You will see what I mean when we look at the results later on. Here it's a small trick. In the JSON schema we use, this example attribute is not mandatory. It's not even standardized yet, but the model will still read it. So I find it useful to include examples in addition to a plain description. For instance, I explained that if you want to find developers named John Doe with Python skills located in Europe, that kind of sentence works perfectly. And I do the same for a project manager in the US. Okay, so that's basically how you proceed. You define this kind of JSON file, defining your tools. And now that I've loaded this file, this JSON file here, now I just have to assign a handler to each one of these tools. This handler will be called automatically each time the LLM requires it. And here you see that I assign this for handler for each one of these tools. It's because we've designed AI Kit in a very convenient way. We can use here directly a class for handler. And if this class has functions with the same names as in my tool definition, here, they will be called automatically. They will be mapped automatically. So here, I just have to assign this as a handler for each tool so that each corresponding functions in my class will be called automatically. So here, I just have to iterate over each of my tools and assign them this as a handler. And all that's left is to call register tools, which is for the AI Kit function, and I pass it the JSON object here enriched with the handlers. And that's it. So now what happens next? I'll open back the class code so that I can explain you. Where is it? It's there. Okay. Okay, it's here. What happens next is that the onData and the onTerminate callbacks and the tools will be triggered automatically. I'll show you in a moment how that actually works. Okay, we'll play here the debugger. All right, and you see that we have here two tool calls to answer this particular query. And the model replies that these people are HR in France. We let it finish. All right, here they are. So we can confirm here in the list box that all of these people are clearly HR in France. Isn't that great? All right, let's see what happens if I just send back another hello here. Okay, so the debugger stops. Let's look at the AI bot. It's here. And here you can see what for the AI Kit does for you. Here, all the messages history are stored. Starting from the first question I asked, so who knows HR in France? Hereafter, the assistant replies by requesting a tool execution, and possibly here, yeah, multiple ones. Yeah, we see it in there. These are the tool invocation requests, and you can see here two tool responses sent back by for the AI Kit, each one with the role tool. Well, let's zoom in a little bit so you can see better. All right. So the role field is important. The user, that's me. The assistant here, that's the model here. The model is asking to call a certain tool whose name is listed right here. And since there's a little ID here attached, for the AI Kit takes care of it automatically by sending the function results with the role tool in here. And finally, you get the final HTML response from the model. The bottom line here is that I really recommend you to use, again, the AI Kit Chat Helper. It will make your life much easier by doing all of this automatically. If you implement the completions API by yourself, it can get really tedious. Okay, let's continue here. We're approaching the end, and I think you can already see the value here, which is really impressive. So let's reload the screen. All right. What's powerful is that you can go far beyond a simple query or semantic search. Earlier, we saw that the model could guess from a sentence that 4 separate searches were needed, were necessary. Now we are going to ask it for something more complex and richer. Imagine I'm driving my car and I'm dictating this prompt to my 4D application. So I need to quickly answer to a call for quote. My client has an upcoming project in finance IT, so we will be looking here for IT skills in particular. The project is mostly located in Italy. The technology stack is 4D, and we need, in fact, to build both a mobile app and a web app, and both of them rely on a server-side 4D database. The project will last a couple of months, and I ask it, can you suggest an adequate team for such project? Estimate the cost for 2 full months and draft me a proposal. And I specify here to start with a 20% margin. So we will be sending this to OpenAI. All right, OpenAI performs the searches it thinks necessary to generate the results in a nice table format here. Okay, let it finish. Okay, selecting a bit too many people. I could have instructed it to form a team of 4 or 5, but okay, we'll refine that later. I get the cost estimation for 2 months as requested. It's drafting a proposal response. It's a bit brief. We could have asked it to elaborate. It's up to you. But right now, so I have a lot of candidates. So here what's really interesting because we can continue the discussion interactively. So for instance, we have Marco Gallo and Fabio De Santis. So two somewhat similar profiles. I can review them and decide. Let's keep here Fabio because he has web experience, while Marco mostly knows JavaScript. So I will type remove Marco from the team. What about Daniela? Okay, Daniela, she looks good. She also knows Kotlin, which is handy, so we'll keep her. Since we have Daniela here for Kotlin, maybe we don't need Adelina for React, JavaScript, HTML, and CSS, and so on. So I type remove also Adelina. Let's now check Giovanni. Giovanni has 4D, Kotlin, Node.js. We can check him here. Yes, it's quite a strong profile. We'll keep him. Let's try something smart now. We don't remove Julia explicitly, but instead we'll say that we do not need DevOps. Isabella Moretti, she can be removed. So I type remove also Isabella. Okay, so to summarize, I just requested to remove 4 people and originally we had 7. So with a bit of luck, we'll end up with a team of 3 people. Okay, let's go. It's working. And yes, I have my 3 people and my updated proposal. Why not continue? What's missing here is probably a project manager. The model didn't find one in its semantic search because if you look at the search, it was mainly focused on 4D development skills. So it didn't automatically select a PM here. So I will type add a PM and I just use the terms, the 2 letters PM. And this time also I specify that the PM should be in France. Okay, it's working. The model triggers a new semantic search and it will understand on its own that it needs to update the table in the results. And now we have here Charlotte Dubois. Of course, here, don't pay attention to the billing rates. They are totally fictitious. Okay, this is a database entirely generated by AI. So, okay. All right, so this is exactly the kind of functionality that I find very interesting. You'll notice that in my first question, there were two tool calls, but in the second one, there was no tool calls at all. The model directly reinterpreted with its context and updated the results. And when I ask for a new information that is not in the context, it will trigger a fresh search. So it's up to you to decide, of course, what data you allow the model to access. You have full control over this because you implement the functions, you implement the tools. What's also very useful is that you can use a cloud inference server like OpenAI for some functions and a local inference server for more sensitive functions, for example. There's absolutely no problem with that. Let's try French now. Liste-moi les experts RH vivant à Berlin. So HR people living in Berlin. I don't know if there's any. Okay, it's working. This time it's not very relevant. And yeah, the model says so by itself. Okay, there's no explicit HR profiles here. I have here project managers. I could tune a little bit the system prompt or the tool definition to avoid citing persons if they don't match. This is totally possible. Okay. All right. Final phase now. I'm going to show you the same process, but this time with LM Studio. We'll use a model I'm familiar with. It's Quint 3. I have several versions for this model. 4B, 4B Thinking, 14B, and 8B. These numbers, they correspond to the number of parameters. More parameters generally mean better quality responses. For the demo on my machine, we'll use the 4B model because the larger the model is, the heavier it is to run. LM Studio provides clear guidance on what can be loaded on your machine. We saw at the beginning of this session the blue icon. Now, we can start asking it questions. Tell me if we have what a 4D experienced people in UK. All right. Just before launching, let's take here LM Studio, we clean the logs, and we send the question. Okay, we see LM Studio responding here. It's a little bit slower than OpenAI. Okay, I get here a tool call for cities and countries. So I guess LM Studio will try to refine the query. And now a tool calling for skills and categories. And back again for cities and countries. It's clearly going into a loop, and this is something I wanted to show you. Okay. What's happening here is that the model lost memory. And it will continue over and over to request the tool. So let's stop it and explain. When the model asked the first time for the first tool call here, I guess we sent back a bit too many data. So it flooded what we call the context window. And as we flooded that, the model only is left with the first prompt, in fact, the first completion. And it's looping over and over, requesting question, flooding itself, and so on. The good thing is that you can play with this context window. You have control of that. So if you go here, if I reset the screen, select again the model, and you can go here in LM Studio and check your model. And here you see we have the context length parameter. By default, it is set to 4000. And clearly, it's not enough to run a proper RAG setup. So you can increase this value. The maximum can go up to more than 200,000. But clearly, the larger this value, the slower the model will respond. And this is where machine power becomes important. And depending on your use case, depending on the tools you have and the data you manipulate, you will have to adjust this value. So let's put it to something like 20,000, all right, and load the model again. So the model will load. Here we see that it has the proper setting. All right, I'm not at the maximum, I still have margin. And here I will ask the same question again. So tell me if we have for the, what was it again? For the skills in UK and fire. So the model is reacting, and here we have a tool call, and here Quen is working a little bit differently compared to OpenAI because it's describing somehow the way it's working, so why he's calling tools and so on. This comes from the prompt I set up initially when I asked it to reason step by step. So here I have a first tool call listing skills and categories, the second one for cities and countries, and then finally the person searched by vector. So here you see that you don't have the beautiful HTML rendering. I guess it's due to the number of parameter of the model. You see that here it's continuing. We'll let it finish. You see it switching between embedding requests and completion requests. And yes, it's finishing. So here you have the answer from the local model here. So what I would have to do here is to improve a little bit the rendering. But everything was executed totally locally. I have my answer, and I have the list of identified persons here, which all have 40 skills and are located in UK. So that's great. And now it's time to conclude. Today we've talked extensively about AI with for the 21 and for the AI kit. First, we saw how to implement a semantic search using embeddings, and then we saw how to set up a RAG, a retrieval augmented generation workflow with tool calling. We've explored how to build a conversational UI whose responses are enriched with your application's data. Of course, you are in control on the data you choose to share with the model, and everything can be run either in the cloud or locally. And for local setups, of course, you need machine power and proper configuration of both the inference server and the model you use. But AI in 4021 and for the AI kit does not stop here, and we will have the opportunity in future webinars to explore other topic and probably very different topic. Finally, I wanted to give you some perspectives for the applications, but also for your end users. I guess now it's a great opportunity to add value and to offer AI-powered features in your applications. The added value will be significantly higher as users expect these kind of features. Sometimes users, they don't know exactly even what they want from AI, but you are in a prime position to provide helpful functionalities. But it's not just about technical implementation. It's also about UI and UX changes. I think that we are moving towards conversational interfaces, probably in a hybrid form, combining semantic search, other queries, and traditional for the algorithm. So the real value for your applications will come from how you will combine these elements effectively. I'm very curious to see what the future holds us for AI and what your talent will bring to you for the applications. And thank you.
Thank you again, Mathieu. So I hope that you find both presentation incredibly interesting. And as you said, Mathieu, giving you ideas how to adapt what you have seen to your application and business. Mathieu, to give you the time to prepare answer, quick announcements. We have new webinars in preparation. End of November, you will be invited to meet the team for a 4021 LTS release webinar. Event will detail all new features from 20R10 to 21 LTS. Session format will slightly change again, more demos, but shorter demos. Then, December, it will be about 4D Cody Pro and user permissions with Marie-Sophie. And in case you would have missed one 4D webinar, please visit the 4D webinar playlist on YouTube, and not to miss any of them, subscribe to it. I think I'm done. Mathieu, ready?
Yes, yes. Okay, we have a couple of questions we'll answer. So, yeah, if the text is stored as unstructured HTML, for example, project description, task, comments, is the search accurate for the text in comments? I think yes, the vectorization, the embedding, well, I think won't give so much importance to all the HTML tags and so on. So it should work. A better way, I think, would be to really for you to extract the most meaningful parts and think about your embeddings, adjusting your embeddings with tasks on the one side or comments on the other side. But I think it would work fine also directly with the raw HTML. No reason. If you have an important amount of text to vectorize, it's also interesting to chunk your text. This is a topic I don't cover here. Maybe could cover that in another webinar. But there's on the forum, there's a couple of components that Keisuke gave, and we have also a blog post about this. If you try to embed a very long text, maybe this text will address different topics and different meanings. So maybe it can be interesting to chunk the part so that you obtain several vectors really targeting a specific meaning. So it can be interesting to work with that. Also because depending on the embedding model you use, they can be limited in the amount of text they are able to vectorize. This is usually documented. Yeah. Our app uses a virtual structure. Each customer has their own use case. They define their table and fields and relationship between them. Great. So they would need to set up some sort of description for each table and fields, right? I need to some sort of training on the AI on their particular use case. Yes, I guess they would need to do that. When they define their structure, when they define their tables and fields, somehow they will have to document what's the meaning of this, what's the meaning of that. Probably, yeah. It seems to be a very interesting topic. I would love to do something like that. You're going to have some fun. Does the AI also look through for the right pro documents or free text saved in the 4D database? So yes and no. The AI does not look through your data. You expose tools that will give data to the AI model. So you choose. So it's not the AI accessing your data. You give data to the AI context. And yes, you can provide for the right pro data. You can even embed them. We have a couple of blog posts about this. So you have all the tools for that. Yeah, so you can build. We have a dedicated blog post about how to search efficiently for the right pro documents. Yeah, so definitely, yeah. Is AI kit included? Yes, it is included, and there's no additional license. It's an open source component. Say you have this prompt: show the top 10 companies by invoice total in the last 6 months. Assume typical table and field names and relationship between table. Where would the embedding object field live? In invoice tables, in companies tables, etc. Or would you need multiple embedding objects, fields in different tables? For this, I think I would probably split into several embeddings. I don't know, depends on how is your model, but I guess yeah. Question: so what 4D version is the demo being presented with? It's 4D21. Very simple question. Thank you. Does the AI kit, when using the RAG or cloud integration, look for fields in the tables that are embedding fields, or do you explicitly tell the tool what fields in the database store, what data? Okay. In fact, to be perfectly clear, I hope AI kit won't look in any table if you don't help it to do so. I mean, you just, when we speak about tools, what we designate by the term tool is just a 4D function that does what you want it to do and returns data in any form, usually JSON, I guess, but it can be anything to the LLM. So AI kit is just orchestrating that, calling the tool you defined. So AI kit does not look for fields or whatever. It just executes what you tell it to do. I think when you will load the demo app, you will understand much better, I think. But you don't have necessarily to map data. You have to describe what the tool does. So in the JSON tool definition I showed you, you have to describe what it does, how it should be used, provide examples, and then the LLM does the rest. Is all 4D AI contained in 4D AI kit? Is it possible to disable all 4D AI if clients have privacy concerns? It's a little bit hard. I mean, for the AI kit, if you want to disable for the AI kit, it's very simple. You just don't declare the dependency. You don't install the component. So this is pretty simple if you want to avoid it. The AI part is not only, it depends on what you call by AI. I mean, having AI kit component in your project does not mean it is exposing anything to any AI. If you don't explicitly plug something in, no LLM will be able to do nothing. So you are in control of everything. There is no absolutely no security risk about that, or no privacy risk. And AI is a broad term. I mean, vectors are not. I mean, for the vectors, they are not in for the AI kit.
Thank you, Mathieu, and thank you everyone for joining us today. Thanks a lot, not to have dropped out, but it was a so interesting session that I really think that you enjoy it and that you learned a lot. That's one of the goal of these sessions. As usual, once you leave this session, you will have the survey link displayed on your browser. Please take the time to give your feedback to help us improve the webinar format. And if after the session, one you will have left, you have any further questions, don't hesitate to share them on Discuss. Mathieu will be happy to answer you. He's monitoring every day Discuss, so don't hesitate. And before you ask for, yes, the source code of the demo application will be shared with you with a session replay link. So thanks again for joining us. Have a great day, good evening, a wonderful night, and see you during our next event. Mathieu, goodbye.
Goodbye. Thank you, everyone.